All right, everybody. So what I'm going to do is show you how to run some very specific descriptive statistics you'll need to complete for your first assignment. And I'm going to use a data set that I generated for this purpose because you have to download the correct data set from the Kendall Hunt publishing site, right? Make sure you get that, and then you're going to upload your results there. I, I don't accept them anywhere else. They have to be uploaded there, and then I can download them for whatever I'm going to use them for wherever I'm going to use them. Okay. So first of all, the two things we're going to need for that assignment is we need how to do frequency distributions, and we need plot. We need a frequency plot. So this procedure called procedure freak, proc freak. So if you type that out, it'll show up, and then we're going to use the data in which the library in which you stored your data set. So in this case, I have a data set 3 stored in the file called HSE217. The tables variable is done to create a table because we have a distribution table here, and the distribution is for the variable sex, and then I'm going to plot a frequency plot, and then I gave it a title, frequencies distribution gender. Okay, I'm going to set frequency if I want. Okay, it doesn't really matter. The reason I said that was because you can put more, you can just say frequency distribution for gender, something, whatever you think is best for your, okay. And then, so let's run that first. So this is going to be for any variable. It's a discrete variable in the data set, and one of them is gender. So you'll notice that I use I put a note here for example of SAS assignment 1. Obviously, that's just a note, doesn't do anything else. So I'm going to go and hit the little running person here, and this should be okay. Okay, so we have 8, in this data set, we have 8 males and 12 females. So these were coded, and because of the coding, I got the male and female here, which makes it much better. And it says distribution by sex, and then the title is participant gender. So I could change the variable to gender too to make it, all consistent. But the bottom line is that we can see move this over somehow, shrink this. Yeah, maybe not. But we have a distribution for gender here. So you're going to need this picture you're going to need both a frequency distribution. Frequency means the n. So if you look in a table, it'll say n, usually that's a count. So there's 8 males and 12 females. And males make up 40% of the distribution, females 60% of the distribution. You also get this cumulated value. This is 8 plus 12 is 20, or 40 plus 60 is 100%. You can't do anything with this from here. So what I do is I'll click this little link to open it up in a new window. And now I can right click here and say save image as copy image. So I can put it in a document and make it look good. Now you can play around with these. There are things you can do with the images to change the colors and stuff like that, but that's through coding. Okay, so that's frequency distribution. Let me go back to where I need to go here, go back to the coding. And the next thing I want to do is work with a continuous variable, right? Or you can call it quantitative, you can call it interval ratio, depending on what it is. And I'm going to remove this. So I was showing people how to divide the sample into 2, but we're not doing that for our assignment. But here I'm going to pick one of the variables, and it's going to be body mass index. Now I have to turn on the graphics here, right? Turn on the graphics and then turn them off when I'm done with them. And within the graphics, I'm going to do a couple things. I have a var command. So the process is called procedure. The procedure is called procedure univariate. And again, we have to say where our data are located. Data are in HSC217 library dot dataset 3 is the dataset name, right? So this is just giving it the location. I note the variable that I'm interested in is BMI, although you can do all of them at one time. You just have to probably make sure you change your title. So in this case, this is a histogram for body mass index, and I'm not dividing it by gender for this example. If you wanted to, you could. So I'm going to get all these interesting statistics for BMI, plus I'm going to get a histogram of body mass index. Histogram is a type of display, and we'll see that in a second. And I'm going to get I'm going to superimpose a normal curve on there just so we can see how our data look compared to normality. I'm going to give it its title, and then when I'm done, I have to hit run or type run and then put the ODS graphics off. So let's run this area here. And don't forget the semicolons wherever you need them. And then we'll run this guy. So we look for the little running figure again. BMI is not in the data set. So, okay, well, that's right, because we're using a different data set. So that's a mistake on my part. So I'm going to go run a quick proc univariate to see what our variables in here are. Oh, I think no is one of them. Yeah, like no one, right? Let's just do no one, no one. And then we're going to call this something else. Oops. So there was no variable name BMI in that data set. There is in your data set. So we get a histogram for this is parental monitoring item 1. Parental monitoring item 1. All right. This should work now. All right, let's run this. Okay, so we have 16 individuals with data on this variable. The mean is 2.31525. Standard deviation. We're going to talk, I told you what the standard deviation is. Well, in this week, I'm telling you what it is, but we're going to get into much more detail about how to use it. We have these statistics called skewness and kurtosis. They tell us a little bit about what the distribution looks like. Is it flat? Is it thin and tall? Does it have tails that are, uneven? So that's what skewness and kurtosis mean. Then we get other stuff here that are not really that important to us right now. So location, we talked about location. The mean is the location, right? You have the median and the mode. When something is perfectly normal, the mean, the median, and mode are all exactly the same. The range, lowest to highest items. Let's see, this is probably not going to, I think it's probably a 4-point item, so probably not going to have a really nice histogram. But let's see. Anyway, so we're not going to worry about that yet. Yeah, let's go to the histogram. So, I figured it wasn't going to be that good because the distribution is 1, 2, and 3, basically. But this is what a histogram would look like. Do your parents know who your friends are? I guess from 0 to 3, or maybe even from 1 to 3. And if it was normal, it would look like this. And clearly that has some issues with normality. But let's see if we can find another variable that looks even more interesting than that one. I'm going to go back here since I can't remember what's in that data set. Did I save it? Let's see if I saved it. No, I didn't. Okay, since I don't know exactly what's in that data set, I'm going to run a proc contents data set 3. I think that's where I have it. So let's run this. All right, so let's see what's in that data set. If there's something else that would be better. It doesn't, yeah, I don't, Hispanic alcohol. Yeah. Oh, age. We can do age. Maybe that'll be a little better, but it's still probably going to be most people around the same age. It'll probably be kind of discrete, but we can just run it just for the fun of it, see what it looks like. All right, let's try that. Age instead. This is good for you to learn how I'm doing this. So we're going to do age and change age here because we're doing a histogram for age and histogram for age. Just change everything to make sure that it makes sense, right? Delete. Oop. Nope. I think that little thing was preventing it. Age. All right, so let's try this and see. You can practice this with your own data sets. Anything better here? Let's see. I just want to look at the figure actually. Yeah, so we're kind of stuck in this odd land where people rate their age. For instance, I'm 14, I'm 15, I'm 16. But again, you get an idea. This one looks even a little bit more normal, even though there's only 3 different values. With continuous variable, normally you wouldn't have a discrete value like 14, right? People will be 14.369, etc. But we only had very few people in this, so it was very, very discrete looking, and everybody wrote their age as 14, 15, 16, or whatever. It was, right? But anyway, so what this graphic does is it adds a curve on top so you can say, okay, do I have a normal distribution? And this is kind of a tough one because again, we don't have that many values there. It looks like only 14, 15, and 16. Those are the only three age groups we had. All right, but anyway, that's how you run a descriptives command. And this is a really nice command because it gives you a lot of flexibility to see many, many different things, right, about the distribution. All right. Thank you.